everyone. Welcome to the Cosmic Pie Podcast, episode 17, season number 4. I'm your host, Wayne Barkhouse.
And I'm Robert Moore.
We are broadcasting live from the campus of the University of North Dakota here in Grand Forks. And before I introduce our very special guest for today, I just wanted to make a point of saying that anything that Robert and I or our guests say is totally our own personal opinions and not necessarily that associated with the University of North Dakota, nor the College of Arts and Sciences, no, the Department of Physics and Astrophysics, or anyone else that we know. If you're mad, fire us. Right, Robert?
That's it. Yeah, come at us.
Now, we do have a live chat feature that's running. Robert's going to be monitoring that throughout the podcast. So if you have any questions or comments that you'd like to make, and if Robert will parse through and see if there's anything there that he would like to bring out and have Seth answer, please feel free to use that feature.
If I may say, we may not get to all the questions and everything. We want to give our guests time to speak, so don't be offended if I don't get to you. So
now, speaking about our guests, I'm very, very happy to introduce Dr. Seth Shostak, who is the senior astronomer at the SETI Institute. And for those that don't know, SETI means the Search for Extraterrestrial Intelligence. He's also been an author of several books, including the one that I've read several years ago, Confessions of an Alien Hunter. So I'm going to show that now. And also, Seth is a host of a podcast that I also have listened to for many years called Big Picture Science. And we have links both to his podcast and the SETI Institute in the description. So you can check on that a little bit later. But first of all, thank you very much, Seth, for joining us today.
Well, it's my pleasure, at least so far.
we'll try to keep it that way.
Stay that way.
Yeah. So, Seth, I've heard you, I don't want to age myself or you, but I've heard you since the 90s, way back when, it would be in the late 90s when I was at the University of Toronto in graduate school. And I heard you on the Art Bell, Coast to Coast AM radio show that many listeners around the world, whether they admit it or not, I'm sure have listened to. And since that time, I've heard you like many times. And I want to start off the podcast by, number one, bringing up something that I haven't really heard that often. And it's related to things that you've written in your book and other stuff that you've done. And that's, can we explore a little bit about what got you interested in astronomy to begin with? And in fact, I would, before you get to the SETI stuff, to kind of give us an idea of what you did your research on in radio astronomy.
Right. Well, I got interested in astronomy at a very young age. I built a telescope. I mean, I didn't grind a mirror or anything like that, but I had built a telescope at age 10. And mostly I used it to check out the neighbors or just to look at the moon and the planets, that sort of thing. It was a fairly small instrument, so deep sky objects were kind of beyond its capabilities. But I was interested in astronomy, as I say, as a kid. And, when I got to university, I studied physics, but in grad school, I studied astronomy, actually. And, that was based on that early interest.
So how do you go from, an optical astronomer, like I consider myself to be mainly an observational in the optical wavelength region, if you like, to being an actual radio astronomer? What was that jump for you?
Yeah, well, that jump occurred in grad school, actually. And the reason for the jump was simply because I had talked to the various astronomers at the school I was attending, and the radio astronomers, they appealed to me, as did radio astronomy, because at that time, radio astronomy was where the action was. It was almost impossible for a week or two to go by without some new discovery in radio astronomy. And that's, of course, because up until then, nobody really had done very much radio astronomy. So every time you point the antennas at the sky, you discovered something new. So it struck me as a kind of an interesting field. And beyond that, I had some, background, mostly as an amateur, really, in electronics. So the idea of radio astronomy struck me, simply on the basis of the technology.
One of the favorite things of looking at radio astronomy when I was young, I remember, is like, here it is, 10 o'clock at night and it's raining outside. If I was a radio astronomer, I might be able to gather, useful data right now.
Yeah, even during the day at 10 o'clock. Yeah.
Yeah, it's hard for people to imagine that, because when you talk about telescopes, they immediately think of optical telescopes, of course, and you got to remind people that's not the only part of the electromagnetic spectrum that we probe. If you're looking at radio, you can use your telescope even during the daytime as long as your object is above the horizon. And I guess the only limiting factor there would be as long as there's not an electrical storm, you're within 50 miles or something of the radio telescope.
Well, yeah, actually terrestrial interference is an issue, but usually not because of electrical storms, mostly because of, the transmitters that exist here on Earth for our own purposes, of course. But those can be very, they can really disturb what you're doing. But in any case, that's why radio observatories tend to be built in places that are fairly isolated because, there's not much, there are not many people around, and consequently, there are not many services that use radio around to interfere with your observations. So you get to spend a lot of time in an isolated place.
Yeah. I mean, the other thing I wonder too is I can't remember, I think it was the Iridium satellites when they were first put up. And there was an issue with the FCC and the frequencies that they were using. And of course, this is my own personal opinion, but it almost seemed like when certain companies says, okay, we are using this roughly narrow band range of wavelengths, but when they're actually in operation, they tend to bleed out, beyond the sort of window that they are given to by the government. And of course, that can affect radio astronomy if they're into areas where we like to observe at. Is there an increasing sort of problem with that, where we have so many satellites now that are going in Earth orbit that we're going to get this even more interference than they had even 30 years ago?
Well, probably that's the way it's been going. And the tension, as you hinted at, is between, astronomy, radio astronomy, but astronomy versus all the, commercial and non-commercial applications of satellite technology. I mean, having satellites up there has real benefit to the general population. And astronomy is very interesting to the populace, but they don't know how they benefit from it. So that's kind of a problem. It's a problem that I think eventually goes away because ultimately you want to move your radio observatory and, in fact, even your optical observatory to places where none of this is an issue, like the other side of the moon, the far side of the moon. You don't have much interference there because you're forever shielded against all the transmitters on Earth. So, eventually that problem goes away. But at the moment, it still indeed is a problem.
Now, we have a professor here at UND in our department, Marcus Algeier, and he does a lot of research on laser communication with satellites. And so one would wonder, if that sort of technology gets better as we go forward in time, that a lot of this sort of communication with the ground will switch to these type of wavelengths, and maybe that will clear up some of that radio interference that otherwise would be there.
Well, I think you're right. It probably will. On the other hand, the thing is that there are benefits to radio communication, and those benefits won't go away no matter what happens in astronomy. So I think there's going to always be a tension there.
Yeah. Now, you mentioned the far side of the moon, Seth. So, as a young person, you learn, okay, yeah, like Jack Burns and others have promoted this idea in the astronomical literature, is let's put a radio telescope on the far side of the moon and use the moon as a shield to block from all the interference we have here on Earth. And then you think, oh, wait a minute, it wasn't that long ago where China puts up a rover on the far side of the moon, and how do they communicate with the Earth? Well, they put a satellite in orbit around the moon. And in the future, you can almost envision that this sweet spot now will be encroached on. And at some point, people may guess, oh, should we spend a lot of money putting a radio telescope on the far side of the moon? All these other companies, and a lot of it's probably going to be, private, not just government entities, are going to have these satellites going around the moon, and they're not going to care probably, when they're on, in view of the radio telescope that they broadcast, a burst of information back to the Earth.
Yeah, well, you're right. I don't know what to say to that. I mean,
Yeah.
that's probably going to happen. And as I say, in the end, the only recourse you really have is to either move the antennas to some place where you won't be trouble. It's hard to figure out where that might be, maybe in space somewhere, on another world somewhere. But it's a constant tension between astronomy and all the practical applications of the use of the electromagnetic spectrum. I mean, I spent some time in Pasadena, California, which is, just 8 miles north of Los Angeles, whatever. So it's in the Los Angeles basin. And they had, optical observatories up on Mount Wilson that had been built in the early part of the 20th century mostly. And, they were troubled by all the light from Los Angeles. So that really interfered with their work. But what are you going to do? You can't shut down Los Angeles, much though those of us here in Northern California would like to do.
we do have a question. It's a reasonably good one. So I'm going to ask, the question is, did you detect pulsars? I'm going to expand it a little bit. Were you involved with that at all?
I was not, actually. The pulsars were discovered in the 1960s, as I recall, sort of mid 1960s. And they were discovered in England, at Cambridge, England, by a young woman by the name of Jocelyn Bell. She was working with her advisor, a guy by the name of Tony Hewish. And they were using radio telescopes, just big antennas, to study the sky. And Jocelyn Bell noticed that there were some places in the sky when she would point the antennas where she would get what she called a little bit of scruff. And this was just, radio signals coming in that were not constant, and they were varying. And those eventually turned out to be what we now call pulsars. So, at the time, I will add this, at the time, nobody knew what these things were. They were making not only radio noise, but they were pulsing. In other words, they were, producing radio noise that kind of sounded like a clock, a ticking clock. And because these pulses were so incredibly regular, the question was, well, what could be making that? And the obvious thought was, well, it was aliens, that they were using radio to produce these clocks, which could be useful for navigation, of course. So it wasn't completely nutty. But, so that idea, which led to the name LGM for pulsars, little green men, that lasted less than a year, I think. And after that, some very clever theoreticians pointed out that maybe these weren't alien clocks. Maybe they were rotating dead stars, which is what they were.
Yeah, I remember Jocelyn gave a talk a couple years ago that I watched on YouTube, and she mentioned that I think with her advisor, Tony Hewish, gave a talk in front of the group in England about their discovery. And I guess it was Fred Hoyle, who was in the audience, mentioned, I think they're associated with neutron star or supernovae, sort of. And that's exactly the connection, right, with supernovae remnants. So pretty smart people to figure that out so fast in that sense. But, I thought of what's a good location to put a radio telescope, Seth? We kind of talked about this already. How about on the far side of Earth's orbit, on the other side of the sun? So you have the sun blocking. Would that even be possible so that your radio telescope is forever, 2 astronomical units away from the Earth on the other side? But even then, it's like, how do you communicate back with the Earth too?
Well, exactly. I mean, how do you send the data back? I mean, that's an obvious problem. I mean, you could have relay satellites somewhere else and sort of do it either that way by sending the signals first to the relay satellites and then back down to the Earth. I mean, there are solutions to all of this, but the problem is they all cost money. And the one limiting factor in almost every area of astronomical research, and particularly in SETI, where I work now, is always the money. It's always the money. It isn't that what you're suggesting is impossible to do. It's just that it's going to cost money. And where's the money going to come from?
Well, if I win the Powerball, Seth, so I'm making a promise right now. If I win the Powerball tomorrow night, I will donate $50 million to the SETI Institute on your behalf. How's that?
That's great. They'll probably name a water fountain after me if you do that.
I'll live forever.
Live forever, the name of a bubbler.
Yeah, too bad it'll be in California. It won't last as long if it was somewhere with less earthquakes, right?
Yeah.
But the other thing, Seth, I want you to drill down a little bit more on what you actually did in your research before SETI. And I thought that you were involved in, and you correct me if I'm wrong, more of the motion of like gas clouds and different types of like spiral galaxies. Is that true, or am I way off base on that?
No, you're not off base at all. My thesis work was studying the motions of gas, neutral hydrogen gas, in spiral galaxies. I had a couple that we were studying, and the purpose of that was simply to learn something more about galaxies. What we noticed right away, and this was the big surprise, is that the galaxies were all moving a little bit, and they were rotating, I should say. They were rotating a little bit faster than we expected. They're all rotating too quickly. And at the time, we didn't know what that was. Uh, Eventually it turned out to be something that we today call missing matter or missing mass. The galaxies were a lot heavier. There was a lot more stuff in them than you could see by just, counting up stars or gas clouds and things like that. So that was actually an important result. Missing mass is still a big deal in astronomy, and we still don't know what it is. But in any case, we do know that it's there.
Yeah, so that's dark matter, in other words, right?
Dark matter.
And it was yourself and others, like Robertson, if I think was one of the people involved in this type of work in roughly that time era.
Robinson doesn't ring a bell, but my thesis advisor was named David Rogstad.
Okay.
And maybe that's whom you're thinking of. I don't know, but
right.
He was doing that with me, yeah.
But this is important. This is before Vera Rubin and Kent Ford and others popularize from optical spectra the flat rotation curve of spiral galaxies, correct?
Well, yeah, they were doing rotation curves of galaxies. It's true, Vera Rubin. And but the rotation curves that they were publishing, they could only measure it out to a very short radius in the galaxies. So they actually didn't see these flat rotation curves, as you call them. But one summer, I had Judy Rubin, who was the daughter of Vera Rubin, as my summer student. And I had her working on these flat rotation curves we were funding. And I suspect she went back and told her mom, in fact, I'm pretty sure of it, and suddenly her mom was promoting flat rotation curves.
You were there at the beginning, Seven. Nobody really knows the story. You're so modest, I think, that you don't.
Yeah.
Yeah.
As someone once said, I have a reason to be modest. But
it could be the Shostak, observatory down in Chile right now that people are using. Right?
Yeah. No, that's true. That's true. But if you work in astronomy, you see a lot of that sort of stuff.
Yeah, for sure.
Right. Yeah.
Now, of course, the big thing.
I would argue that you see it in almost every field.
Probably, yes.
Yeah.
Yeah.
So what got you first interested and eventually leading you down the path towards SETI? What was your first kind of experience in that?
Well, I suppose that dates to the time when I was working in Charlottesville, Virginia for the National Radio Astronomy Observatory, better known as NRAO, and using the radio telescopes that they had in Green Bank, West Virginia. And, following up on those studies I had done as a grad student of the rotation curves of galaxies, actually. And, it was often the case, almost invariably the case, that you had a certain block of time allocated to you to do whatever you're going to do. And I was studying these galaxies, but there would be certain hours of the day when there weren't really very many galaxies to point the antennas at. So you had the telescope time, but you didn't have too many objects to study. So at that point, what I would do, and nobody knew I was doing this because I hadn't put in an observing request for anything. I kind of did it sub rosa, but I would just go into the library there at the observatory and find 50 nearby stars, preferably stars like the sun, and write down the coordinates and just point the antennas in those directions when there weren't any galaxies, with the idea being that there might be planets around those nearby stars that had societies with transmitters. So that was a SETI search, completely, it wasn't refereed by anybody. I just did it. I didn't find anything, lamentably, but that's what was happening. And that got me interested in SETI.
So when you did this, and did you know about what Frank Drake had done prior in his sort of beginning search?
Yes. Frank Drake did his experiment, the important experiment in 1960, I believe. And, he was using actually some of the same antennas that I eventually was using there in West Virginia. And he did it pretty much with the same sort of motivation. I mean, they had just built a new antenna in West Virginia at Green Bank, what was called the 140-foot antenna because, well, the diameter of it was about 140 feet. So, they had this antenna, and the director of the observatory told Frank, who was a young postdoc at the time, they said, Frank, think of something to do with this big antenna. And one thing he thought of was, let's try and find ET. So that was the first SETI experiment, and as I say, that was in 1960.
And before you even do an experiment, like in science, we always say, well, you never know, because I mean, the airwaves could have been buzzing with activity for all we knew.
Yeah, that's true. But I think that goes back a little earlier, because when the first radio observatories were built, or radio telescopes were first used to study the sky, nobody knew what would happen if you turned a big antenna toward the sky. It could very well have been, that indeed there were lots and lots of sources of radio waves. Well, there are. I mean, there are quasars, pulsars, all the stuff. But, the sky isn't filled with radio noise, and it could very well have been, but it's not. And that was actually an untouted, but nonetheless kind of surprising and important discovery in the early days.
I mean, it really puts a constraint on and life in some sense, right? It's like, what are the conditions or ingredients for life? We know of only one place in the universe here. But if there's life almost on any sort of suitable, and we're so biased, of course, because of who we are and where we live, that life could have been, almost guaranteed in every solar system on average. And that doesn't seem to be the case, or at least we haven't been able to detect such a thing. Is that true?
Yeah, well, that's true. I mean, you could say that we have no idea what fraction of stars, or even stars like the sun, have planets sort of like the Earth with, technologically competent critters on them. We don't know that. But on the other hand, I think you have to be a little careful and not say, well, the fact that we don't find, radio signals from every spot on the sky means that there aren't any interesting aliens out there. Eventually, radio, aside from, radio astronomy, which is a passive endeavor, doesn't involve any transmitters. Aside from that, it could be that eventually what you use for communication is not radio if you're an advanced alien society, but you use lasers, which can convey many more bits per second of information than radio can. So it may be that the sky is actually laced by laser beams flashing at one another, and the chances that we might be in a beam so that we could see it are probably fairly small. So you haven't ruled out the possibility of a lot of chatter in the galaxy.
Yeah. Now I remember looking at some material. It was around the time somewhere in the 60s, and I don't know if it's from NASA or not, I can't remember, but it was like Project Cyclops, where they got this illustration of a huge number of radio dishes, and of course that never came to fruition, right? There wasn't the money eventually allocated for that. Was that a NASA project that they were looking at, or was that something else?
Well, it was a NASA. I mean, NASA was doing a big SETI project actually, and a lot of that was motivated by this proposed idea, Project Cyclops, which was mostly the idea of a fellow by the name of Barney Oliver. Now, Barney Oliver was the head of R&D, research and development, at the Hewlett-Packard Company here in Palo Alto, like 10 miles from where I'm sitting. He was one of the cleverest people I ever met, and I've met some fairly clever people, but Barney was you had to be careful with Barney. If you made any statement at a dinner or whatever, and Barney was sitting there, he would usually respond by saying, "Why do you say that?" And you knew you were in trouble then, because unless you had some very good reason to have said that, he would take apart what you just said. But he indeed conducted a summer study, and I think it was indeed funded by NASA. But anyhow, he had a summer study in which they looked at the whole question of building telescopes that might detect the aliens, radio equipment mostly. That was called Project Cyclops. And that was and still is largely the handbook for all SETI experiments. You can find it online, I think.
Yeah.
We are getting some questions from apparently some high school level and age people, and they are curious about how you would work with and deal with radio astronomy as opposed to optical astronomy, especially at their age range. So is there anything you can say on that? Anybody they can contact, people they could ask and work with?
Well, all I can say is, look, if you're interested in radio astronomy, you want to do it as a living, so to speak, then I only say so to speak because it doesn't pay all that well. But yeah, you just study the usual things you would study for any astronomy career, which is to say physics, right? Physics, math, that kind of thing. And so, it isn't that there are many courses at the high school level in radio astronomy or any other kind of astronomy, really, not at the high school level, usually not. But, by studying those things that would be useful to astronomy, as I say, mostly physics, mathematics, electrical engineering, electronic engineering, that sort of thing, then you can, sort of shape your career path after that.
Okay.
There we go. So, how did you end up meeting with Jill Tarter? Everybody who's into SETI or knows about it knows of Jill Tarter, also besides yourself and Frank, and they related to the movie Contact. Written the book by Carl Sagan and so on, and that was supposedly the main person that Ellie Haraway, if I remember the name right, that was focused around Jill a little bit because I think Carl Sagan knew Jill Tarter. So, how did you end up running into her, and then obviously working together as colleagues?
Yeah, well, Ellie Arroway in the form of Jill Tarter actually came to Charlottesville, where I was working as a postdoc. And she came there, she gave a talk, and she was talking about, how she was trying to find ET by tuning in ET signals on the radio. And that was very interesting. I got involved, very soon thereafter, actually. I was involved with projects together with Jill on SETI experiments, stuff like that. She was a wonderful person.
Yeah, I mean, and in the movie, one of the things they come across is the fact that people, like other scientists, at least some of them, and the government officials, there was a head of the funding agency that was one of the main characters, of course, that later got killed, in an accident that was done, terrorist attack. But the idea that you initially get time on these large telescopes, let's say like Arecibo, and then people find out what you're doing and then say, okay, maybe you should be doing real astronomy, if they ever use that phrase. Did you guys ever, experience that type of, not hostility, but negative sort of view towards what you were doing?
No, personally, I did not. I mean, I'm sure that if you took a poll of astronomers at the time and said, do you think that doing SETI work with these instruments is a good use of telescope time? There undoubtedly would be some would say, no, much better to study things where we know we can learn something like quasars or pulsars or whatever. And that SETI is, not ever going to pay off, and we could be using the instrument for something else. But, I honestly think while there were some people who had that point of view, I think it was a minority point of view because they all recognized that if SETI paid off, if you picked up a signal coming from some, other society, that would be a result of enormous consequence. And so there you had it. I mean, maybe you're not going to succeed, but if you do, it's really important. So I think they mostly recognize that.
Yeah, it's one of those enterprises where it could pay off tomorrow, or it could be 500 years from now. But but if you don't do the experiment, it's like then you'll never know, right? It's that kind of a thing.
Well, yeah. I mean that point is sometimes made that if you don't do the experiment, you'll never, get any interesting result. That may or may not be true, actually, because a lot of interesting results in astronomy are the result of accident. So finding the pulsars was an accident in a way. So maybe you will find things even if you don't do the experiment. But obviously, it seems reasonable to assume that your chances of success are better if you actually try and do the experiment.
Right. Now, I know Arecibo collapsed just a couple of years ago, unfortunately. But at that point, had you guys moved on to, like the SETI Institute, had moved on to like the Allen Array, the Paul Allen, I believe it was, that paid some money towards building this array? And is it Northern California, I think, in the Owens Valley area?
Yeah, it's not in Owens Valley, but it is in Northern California.
Okay.
And it's about 3 hours north of San Francisco, in the mountains, so somewhat to the east. But the Allen Telescope Array, it's I think 47 antennas, and they're relatively small antennas. They're not as big as Arecibo, which was at the time the largest single dish antenna in the world, and probably would still be if it hadn't collapsed. But the trouble was we used Arecibo. I enjoyed going there a couple of times every year, and sit there in the control room in in Puerto Rico. A lot of good chicken and rice, and and actually, what I really enjoyed about it were the Puerto Ricans because they were incredibly nice people. But in any case, that observatory eventually collapsed. But even before that, we began working on building the Allen Telescope Array, not because it would be better, because you could take all 47 of those antennas and throw them into the Arecibo antenna, and they would get lost. The Arecibo antenna was 1,000 feet across, so it could hold a lot of these smaller antennas. So it was by far the most sensitive radio telescope around. But as I say, it had the bad form to collapse, and wasn't rebuilt. There was no money to rebuild it. So we fortunately by then had the Allen Telescope Array, and the big advantage of that, even though it wasn't the biggest radio telescope in the world, it was one that we could use 24/7, and that was an important step forward.
Okay, so you didn't have to share the Allen array with any other astronomers?
No. We could use it it was used for other experiments, but if we'd said no, we just want to do SETI on it all the time, we had the ability to do that, but we didn't. We figured it was probably a good idea to also do other experiments with that antenna, because that array, because that would foster the development of new equipment, new software, whatever.
Yeah, because a lot of the times you can sort of piggyback your someone could piggyback observations that we're doing if you're pointed in something interesting location on the sky and you're doing your SETI stuff and somebody else is collecting data for their project simultaneously. Is that true?
Yes, that's not only true, but it's the way the Allen Telescope Array generally operates now. Okay. Altogether. So you have conventional, if you will, radio astronomy taking place, but at the same time, you're also doing SETI work. So that's right. The best of both worlds.
Now, I know China now has the record, right, for the FAST telescope, right, the 500-meter, I believe it is, diameter aperture telescope. And they're doing some SETI stuff. I see the odd, preprint come across AstroPH or something once in a while. Do you have any feeling for I don't want you to be negative against anybody, but do you have a feeling for what that instrument could potentially do in the SETI field?
Well, it's obviously a very powerful instrument, and it's far more sensitive than anything that we have here in the West, right? Again, the Allen Telescope Array could get lost in the FAST telescope. It's very big, as you just point out, 500 feet or whatever it is across. And so it's very, very sensitive. But on the other hand, it looks at a tiny, tiny patch of the sky at any given time. That's the downside of a single dish antenna, because it's, usually it's kind of zeroed in on a tiny patch of sky. It's, great for looking at nearby star systems where you don't need to look at a big patch of sky. But if you say the best strategy for finding ET might be to survey as much of the sky as you can, then that's not the right antenna. It's better to have an array like the Allen Telescope Array.
So we have another question, and that is what would happen if we did find an alien signal and where it was coming from really far away? What do you think would happen?
Well, I think it'd just be rioting in the streets. No, actually, no, I think what would happen is people would find the result very interesting. By the way, there was no way you could cover this up. That's a common belief that I find when I talk about this sort of in the general public. A lot of people think, well, if you found a signal, you wouldn't even tell us, which I find a very peculiar point of view. But, and when I ask people why wouldn't we tell you? And they say, well, because the public couldn't handle the news. Well, that's kind of silly because, the majority of the public already believes that not only the aliens are out there, but a fair fraction of them also believe that the federal government knows about it and is covering the whole thing up. So they already figure there's some sort of conspiracy to hide this information from them, and they're still not rioting in the streets about it. So I don't think that would be the case. I think it would just be a very interesting discovery, and there would be immediate follow-up by every antenna on the planet that could reach that object and tune in whatever's coming from it.
Right.
I mean, Robert and I were talking the other day, and one of the things he mentioned was the wow signal, right? Because I'm sure you're sick of hearing about that, and that was a one-time off thing, and it's like, chances are it's just interference, earthly terrestrial type of noise, but without repeatability, you just don't really know what it was, right? True?
Right.
Yeah, no, that's right. The wow signal was picked up at the Ohio State Radio Observatory, which has since then been, dismantled. But in any case, it was a pretty big antenna used for radio astronomy, but it, eventually was turned to mostly just surveying the entire sky, looking for signals that were narrowband. In other words, signals that might be produced by a transmitter as opposed to something natural. So it was doing SETI work, and it was all automated. So, it didn't cost the observatory very much because you didn't have to pay a lot of salaries. And it did indeed. One day, a guy by the name of Jerry Amon, he was one of the astronomers there in Illinois. He came in to check out the results of the past 24 hours or whatever it was. And in those days, the output of the antenna was always directed to a chart recorder, which was essentially, a pen on a moving sheet of paper, and, with squiggles and so forth. And there was one big squiggle, and he wrote wow next to that on the chart paper, and that became the wow signal. And it, had all the characteristics of a signal produced by a transmitter. So people got rather excited about it, at least at first. And so they went back to that same position on the sky, same frequency on the dial, and didn't find it again. And it has never been found again. Many people have tried, particularly, obviously people at Ohio State tried again, but other observatories, in fact, I've done some experiments myself where you point to the same position on the sky, hoping to pick up the wow signal, and we never have. So the question is, well, what was it? Well, maybe it was ET, and ET got bored after broadcasting for an hour and then went off the air, never came back. That's one possibility, but you can't do much with that. And the other possibility, and this is the general opinion, or at least it was the opinion of the people at Ohio State whom I asked about this very result. And they said it was probably just terrestrial interference. In other words, it was intelligent life, but humans.
Right.
Right.
If you had the same instrument available, you could monitor with it, and assuming that it might be a repeatable terrestrial signal, right? So you could pick it up again and again, but...
Yeah, well, that might be. But they didn't ever find it again. So, no matter what you think it was, if you can't find it a second time, then it's not really science anymore.
It's like someone opened the microwave door and flushed the toilet at the same time or something nearby.
Yeah.
It's like the fast radio bursts, right? Initially it was they seen what the detections were happening around lunchtime, and it was people popping open the microwave door before the timer went off and the microwave shut down, and you get that blast of microwaves that would leak out. And then around that time, they actually discovered, fast radio bursts. So it was a new phenomena, right? So it was kind of strange there, but
yeah, well, I use that microwave. It's the one at the Parkes Radio Observatory in Australia. Mm-hmm. Indeed.
Right.
I will bring up that they don't recognize this anymore, but I remember I changed out the radio in my truck one time, and for a while before I learned how to filter the signal out, you'd get this whine that would ramp up when you push in the gas. And it was because the vehicle's engine through the alternator was producing radio waves.
That's the ignition system, right? Ignition system. And that's why if you go to a radio observatory, if you go to, for example, the Allen Telescope Array in Northern California, you can't use a gasoline, powered car with an ignition system on the site, or at least they try and minimize that. And that's also true in West Virginia and so forth. Radio observatories in general, because automobile ignition systems, they're just spark plugs and distributors and things like that. And they're very noisy. They make a lot of noise all over the radio band. So they really get in the way.
Yeah. You just got to, for those who, I'm sure everybody experiences, you just turn on the AM radio when you're nearby an electrical storm and hear all the noise on that compared to FM.
Mm-hmm. Yeah.
Yeah.
And here's the great question. We finally got it. If we would get a signal from a potential alien life, how would we even recognize the signal? What are we looking for?
Yeah, well, that actually is indeed a good question. Because the universe produces a lot of radio waves, right? We've talked about several of them here, quasars, pulsars, all that stuff. But if it's a transmitter, if it's ET, one characteristic that's really hard to miss is the fact that it would be narrow band. In other words, it would be at some frequency on the radio dial there, but only at that frequency. And if you tuned away from that frequency very much, you won't hear it again. So it's like tuning your radio, your FM radio, whatever, at home. You tuned it to one station there, and you get a signal, but you don't have to turn the dial very far before you don't get that signal anymore. And that's unlike things like, quasars, pulsars. A quasar, makes its radio noise, but it's essentially all over the dial, right? Whereas the signal from a transmitter won't be all over the dial, and that's how you could recognize it. That's step one. Step two in recognizing it is to try moving your antenna around and make sure that the signal is actually coming from one spot on the sky and not from, the neighborhood, if you will, from Earth.
Right.
So the other thing that I always find curious, Seth, is, you hear about, it's a technical term, so I apologize for using it for people who are not quite familiar with these terms, interstellar scintillation. And so that is a drift, right, of a radio signal coming from a distant object. It can be a natural objects. So what impact would that have on, honing into a signal from, an intelligent civilization that's broadcasting?
Well, interstellar scintillation is, that was discovered a long time ago by radio astronomers. And it just means that if you look at a source like maybe a quasar, right? Quasars are far away. They're the nuclei of galaxies. So they're not even in the Milky Way galaxy. They're far away. And as a result, they tend to be very sort of small on the sky, right? And they scintillate. In other words, if you, point your radio antenna at them, the signal will vary. It'll, go up and down. It'll flash, whatever. Not in a regular way, but it will scintillate. It's like stars twinkling, actually. And it's pretty much the same effect. It's not because of the atmosphere, but it's because of gas, mostly hot gas, in our galaxy that's causing the signal to, fluctuate. So it's useful for some experiments in astronomy. It's not so relevant to finding ET.
Yeah, but if you're looking at a narrowband signal, that you just get like a shifting around type of thing, right? It wouldn't be stationary at one frequency or something to peak.
Well, maybe not, but I mean, scintillation in general doesn't shift the frequency very much. It usually just affects the amplitude.
Okay, and of course, if it's really far away, like a billion light years, we're not going to detect that anyways with the equipment that we have, right?
Well, I mean, it depends on how much money the aliens spend on their transmitter. I have to say, a billion light years is, quite a distance. So.
Assuming they have money.
Yeah.
So what about several years ago, Yuri Miller, I think was his name, the Breakthrough Listen project. So he put a bunch of money into a different organization than yourself. And so what's come out of that? Did they just buy telescope time and that's the sort of idea with that?
Yeah. Well, Yuri Milner is he's a clever guy, actually. He studied physics in Russia, but he doesn't live in Russia anymore. He lives actually, I think, here in California. I've been to his house actually a couple of times. Anyhow, he made a lot of money, and he thought that he would use at least some of that money to fund experiments that don't have very much money that might, be long shots, but if they paid off, would be very important. So, one of the things he's occasionally funded is indeed SETI. And, he recognizes the fact that, okay, maybe if they had regular funding, people doing SETI, they might find something, in which case that would change the world. So, the government isn't going to fund it, so he has put up some money.
Cool.
Yeah, and then speaking about the government, weren't they promising, or NASA was going to, i.e. the government, was going to fund SETI research, and then there was like a senator or somebody who kind of thought it was a foolish sort of exercise, and he managed to convince everybody else not to approve the appropriation of the funds.
Yeah, that happened, when was it, 1995, 96, I think. I wouldn't swear to that, but in any case, it was shortly after the NASA SETI program got underway. because people like Barney Oliver that I've mentioned earlier, some people recognize that, maybe the reason we haven't proven that there's somebody out there that said he hasn't succeeded, maybe the reason for that is that we simply haven't done the experiment in a systematic way with enough funding to, build the equipment and to use it, which, I think is probably right, all of that. But so, in fact, there was a NASA program and in the 1990s, and the idea was that they were going to fund the development of, receivers and other equipment that you needed to do this experiment, and then they were going to fund the experiment. So it would be a systematic search. I mean, I don't know what you can liken it to. Maybe, to people in Europe in 1490 or whatever, think, well, there's all this water here, the Atlantic Ocean. Maybe there's something interesting on the other side of it all. But we're only going to learn that if we can fund some ships to, try and cross this water. And if you don't do that, you might never learn anything about it. So that's what happened. So for a while, there was a SETI experiment by NASA. It was, to be honest, the best funded SETI experiment ever. But it was killed only less than a year after it was started by a congressman from Nevada, of all places. And this guy, he was trying to make a name for himself by trying to show that he was against government waste. And he introduced an amendment in the Senate late at night when nobody was around to kill the NASA SETI program. And they did kill it.
Wow. It's hard to imagine somebody from Nevada not taking any gambling on this.
Yeah. Yeah.
Right?
But the guy's name was Richard Bryan, by the way, if anybody cares. But he was a guy, I don't think he's still in politics. I don't know.
Yeah, and the unfortunate thing is you look around, not to get into politics too much, look around today and see what money's being spent on compared to back then. It just makes you want to shake your head for sure.
Yeah, well, I mean, at the time, I reckoned that the NASA SETI program was costing the American taxpayer 3 cents per year. So, that was the deal. That was the trade-off. Maybe we'll find ET, but if you're not interested in that, you at least save 3 cents per year.
And it's not like you're sending the money on board a rocket ship and blasting it out into deep space, right? It's being spent.
Well, there are a lot of things that we spend money on that are a lot more significant financially than that.
Yeah. Now, I got to ask you, Seth, because it's been in the news a lot in the last couple of years or so, whatever it's been, and that's this whole business now. They don't like to say things like UFOs. It's this, UAPs, unidentified aerial phenomena. And I know you've said many things about this in past interviews, and when people see videos coming from like the military, and they're like, look what we saw, we don't know what it is. Number one, I don't trust the military in actually telling the actual truth, right? Number two, the videos that I'm familiar with, they'll show like missions like even Space Shuttle. And you can clearly tell, because I've seen this during the missions themselves, where anytime the shuttle would turn on a thruster and the vehicle moves, you'll see these white particles going by. There's like ice crystals that are falling around the shuttle. And that's all they are. They're not, spacecraft zipping around. And then people will bring in, like, even in Apollo 11, the first landing on the moon by humans, how Buzz Aldrin had said something, but he was saying, I can see light reflecting off of pieces of our ship, essentially, that we let go when we pulled the lunar module from the third stage of the Saturn V. And every once in a while, the alignment is right. You see this flash of sunlight, but he never said, this is a UFO and all this kind of stuff. So I don't, and then the interesting thing, so the other week, and you may or may not know this, there was somebody on the internet doing an interview with a Canadian media outlet. So there was a meeting, I guess, at the University of Toronto about UFOs and that kind of stuff. And one of the persons that they were interviewed made a statement that, look, there are all these UAP stuff is happening everywhere, people seeing all these sightings. And, they're even seeing it now in the Strait of Hormuz. And I'm like, well, no wonder how many drones and other military stuff was flying around constantly, because that's the hot spot, obviously. And just to follow up the statement, and I'll let you respond, Seth, there was a show on TV, and I won't name the network or the show, that tries to be legitimate and look at different archaeological sort of things. And they got on the UFO topic and went down to Arizona, like Sonoma, Arizona, where someone that reported that every night when you come out here, you can see UFOs. So they brought, like looks like the military cameras, you can see at night and all this stuff, intensifier, and they look up in the sky and you clearly could see it was satellites that you were seeing, right? It wasn't UFOs, right? It was, unless you don't know what they are, obviously, I guess to you, they're UFOs, but there hasn't been a single thing, and I've been an amateur astronomer since I remember, right? Way back when I was knee high to a grasshopper. I've never, ever seen anything, and that doesn't mean there isn't anything. I've never seen anything in the sky that I couldn't explain or knew what it, had a reasonable idea what it was. And there are literally tens and tens of thousands of amateur astronomers all outside any night. And where's all the reports from them of UFOs?
Yeah. No, absolutely right. Absolutely right. I mean, UFO, the important word in there is the U, the unidentified. It doesn't mean that these flying objects are somehow extraterrestrials. As you just alluded to, the facts are that we have, I don't know what it is now, but on the order of 8,000 satellites orbiting the Earth. And you can see these things if you want to see them. I mean, you just go outside at night, and if you know which direction to look at, you can see these things flying, across the sky as they orbit the Earth. And if you don't know about them, you might think, oh, well, these are aliens, which is certainly one interpretation. But, they could just be engineers in Florida. So, they're not that alien. But, the UFO community is vast, and they like to think that indeed the aliens have come to Earth and, they're buzzing our skies. The government knows about it and is keeping this all quiet. That's fundamentally the story. And the TV people will run with that because it's obviously a lot more interesting than to say, well, these are just satellites that people think are alien spacecraft. I mean, that's not very interesting. So, it's a story with legs, but I don't think it has anything to do with aliens. If it did, I think you'd have lots and lots of scientists working on that problem. If they thought, doggone it, the aliens are not only out there, but they're in our sky around, or they're hearing some static in their earphones, and it's not quite as dramatic. But indeed, you can do it. I mean, just look up amateur radio astronomy and type that into your search engine, and you'll find opportunities there.
Yeah, just to mention, here at the University of North Dakota last year, I built one of these antennas that you can detect the 21 centimeter line of neutral atomic hydrogen gas from the Milky Way. And it's really not that fancy. You just have, an amplifier, and it's hooked up to a Raspberry Pi with a converter and stuff. And there's lots of things out there that people have available at reasonable cost.
There are definitely kits and everything. You just, you've got to go out and look for them a little bit, do some good searches. I'm not a radio astronomer, so I can't help, but
I think that actually is part of the problem, because, amateur optical astronomers, if you will, the ones that, grind their own mirrors or whatever, just buy something, whether it's a refractor or reflector, they actually can do some projects that have real merit for astronomy research, right? But the radio astronomer amateurs can't really do that, because in radio astronomy, you really have to have a big antenna in order to do something that's new and valuable. And that's not true with, optical astronomy. So there is a difference there.
Yeah, for sure. Now, Seth, when I read your book, Confessions of an Alien Hunter, one of the parts of it that I found extremely interesting is the story that you tell about something that happened where, at least for a period of time, you thought you hit it, right? That you found the big one. Do you want to say a little bit about that, what ultimately happened, and maybe, the people's reaction around you, and then what ultimately was the resolution of that?
Yeah, I'm trying to think. I mean, there've been, if you sit at a radio observatory and just look at what's happening, I did this once. I noticed that roughly every 3 minutes you pick up this was true down in Puerto Rico. Every 3 minutes you pick up a signal that look interesting, right? So, just because you pick up a signal doesn't mean it's ET. But there was in an episode, an event, whatever, back in, I don't remember exactly what year it was anymore, but we were using the Arecibo telescope in Puerto Rico, as I say, and it did pick up a signal that looked like the real deal. And it turned out that this happened when I was talking, or at least in correspondence, with a science reporter at the New York Times. So he kind of ran with his story and said, these guys down in Puerto Rico may have picked it up. They may have finally found the big one. And that became, for a while, a big story, actually. There were other cases that involved hoaxes and things like that, where people would call in and say that they had an antenna in their backyard and they had picked up, ET, that kind of thing. That happened at least once, and that was a big story too, because the press don't know how to evaluate these claims. And the best thing they can do, of course, is to open up their Rolodex and call up somebody that they know who actually does this for a living. And those people will say, well, it's probably not true, and this is the reason. But, failing that, then they're going to maybe run with the story, and that occasionally has happened. So, the bottom line is, if any credible signal had been picked up or is to be picked up, it'll, be immediately followed up by a lot of other observations, and you'll know very quickly whether it's what we're looking for or not. There's no way to keep that quiet, and you wouldn't want to keep it quiet. And besides that, if you picked up that signal, you would want somebody else to verify it, and they're not going to be quiet about it either. So,
yeah, I think the case I'm thinking about is it ended up being the Soho spacecraft, is what it turned out to be, the origin of the signal, if I'm not mistaken. And it's like the movie Contact. That's one part they definitely got right. So one of the things they did immediately was they went off source and then back on source and then off source again, I think, and back on source. And then they called up people from Australia because the object was getting low in the sky, and they were able to pick it up and verify it. And so you want this continuous monitoring if you can. And so you'll never keep that a secret, right?
Right.
No, and I was one of several, I think, consultants for the film Contact. So obviously those sorts of details they would get from the people who are really doing SETI.
Right.
Yeah.
Got it.
I just have to bring up, people are like, oh, no, they would keep people from talking about it. And it's like, I don't know if how many scientists people have met, but you can't shut us up. You get us on the topic of what we are enthusiastic about and what we know. You can't shut us up.
Yeah. Well, that's absolutely right. I mean, in this case, you're not going to get tenure for keeping a discovery secret.
Right.
Right.
Or funding.
It's just not going to happen.
Now we're getting long in the tooth here for the podcast, but just to kind of get near the end here, can you sort of reminisce a little bit about what things were like when you first got into the SETI field and what it's like now when we got so many of the discoveries since the mid-1990s of extrasolar planets, planets going around other stars that, at first it's like, are there any other planets besides our solar system? And now statistically, we could make an argument that there's probably at least one, if not many planets orbiting almost every star statistically in our own galaxy and beyond. So that would definitely increase the odds of locations, one would think, where intelligent life ultimately would arise, and therefore maybe increase the odds that they would be detectable going forward.
Yeah, I think you've hit on it. I mean, I occasionally get asked, so, all right, the first SETI experiment was Frank Drake's in 1960. What has changed since then? You still haven't found anything. And I think that my usual answer is to say exactly what you just said, and that is, well, we know some things now that we didn't know then. Back in the old days, if you will, the assumption was that there were a lot of planets out there with intelligent life, and some of them would be broadcasting signals we might pick up. But we didn't even know if there were a lot of planets out there. We knew about the ones in our own solar system, of course. But what we now know is, as you say, almost all sun-like stars have planets. Maybe 1 out of 8 of them has a planet even somewhat comparable in size and mass to the Earth. So, there could be just a lot of good real estate out there for the aliens to inhabit. And, most people would have said, oh, well, that doesn't sound all that remarkable. Maybe it isn't, but it would have been to say that 20 years ago, 30 years ago, because we didn't know it was true. A lot of people assumed it was true, but, that's not necessarily very good for science. So you have to actually have the measurements. And now we know that planets are very, very common. Some of them are going to be the kind of planets with atmospheres and oceans, and some of those presumably will have developed not only life, but even intelligent life. all of that's new.
Really nice. Okay, Seth, well, we'll come to the end of the podcast. I want to thank you very much for being our guest this evening, and we'll give you a chance to and say any closing remarks that you might have. But at the end of every podcast, we always give a quote or an excerpt. And so today's, if you forgive me, it's an excerpt from your book, Confessions of an Alien Hunter. And so here's the statement. And remember our bet.
There we go.
If I win tomorrow night, you got it.
All right.
So thank you all for listening, and we'll see you next time. Thank you.
Thank you, folks. Y'all have a great night.